Here is the dashboard showing the current status of my Spring Boot application. Let me make this little bit bigger so that you can understand this properly. This graph, this one, is showing traffic analysis of the application. Here, this green line represents 200 status code, that is successful response. It looks great, it's all green meaning successful request, but that green line is a lie. Look at the CPU load. It's pinned at 100% and it's red. We are burning through expensive cloud resources just to process a flood of spam. We are not crashing it yet, but we are letting one attacker hog the entire system, slowing it down for everyone else. And it will eventually fail at some point with more requests. Let's fix this. I'm going to enable our rate limiting feature. Here in this Postman, the rate limiting feature is currently disabled. We can send request to this URL to enable or disable rate limiting feature. Let's make this enable to true and send a request. Our rate limiting is now enabled. Now back to the dashboard and watch the difference. This green line, the actual word, has dropped to a safe, steady level, and all that excess traffic is now this yellow wall. That is HTTP 429 status code. That is for too many requests. The application is rejecting the spam before it washed our CPU cycles. And look at the graph of the CPU. The CPU is back to normal. We saved the server simply by saying no. In this video, I'll show you how to implement this production grade rate limiting feature. Here, what we can expect from this tutorial. In this video, we are going to focus purely on Java code to implement this protection. I'm not going to show you how to implement this graphical dashboard. That is another topic. Letting this in this single video will waste your valuable time. If you really want to learn how to make this graphical dashboard for monetization, please mention in the comment. I'll try to make a separate video tutorial on this. However, I don't want to leave you empty-handed. Check the links in the description to download the Rate Limit Lab kit. It includes all the source code and step-by-step manual to set up these exact visualization on your own machine. Okay, let's not waste our time and get started. Here, I have a Spring Boot project open in my IDE. On the left sidebar, you can see the files and folder of this project. This is a brand new Spring Boot project. At this time, this has only one class, and this class contains the main method. Okay, let's open pom.xml and show you the dependencies I have added. This is the project information. We are using this Spring Boot version 3.5.9. Here is the group ID, artifact ID, and other metadata. And I am using Java 21. For Spring Boot version 3, you need to use at least Java 17. And here are the dependencies I have added. I have added Spring Web, Spring Security, and the Redis dependency for Spring. I am going to store the bucket information in the Redis. That's why I have included it here. And in real production server, this data usually stored in this Redis. Now, let's create a controller and check if we can get the response. Inside root package, create a new package, controller. Inside controller package, create a new Java class. Let's name it test controller. Annotate this with REST controller and add request mapping to API/public. Inside this test controller class, add get mapping. This points to hello, public method, string hello, returns a message, something like hello. If you see this, you are within the rate limit. Great. Now let's start the project. Now I will check this with Postman. Open a new tab. This is get request. The URL is localhost. Application is running on port 8080. Then the endpoint /API/ public/hello. Send the request. Here it shows 401. That is because we have included Spring Security dependency and it requires us to authenticate. Here in our pom.xml file, this is our Spring Security dependency. Let's comment out for now and refresh the Maven dependency by clicking this icon. Again, restart and back to the Postman. Send the request. Now we're getting the response. Perfect. Now what I will do is that I will add rate limiting. If someone sends request too many times to this endpoint, in the real world it may be 100 times per minute or more depending on your requirement. To simulate that kind of situation, let's say if anyone from a specific IP sends request more than 10 times per minute to access this, we'll block the subsequent request. After 1 minute, the quota will be reset and the user will be able to send 10 requests again. That means any user can send 10 requests per minute. It's just for demo purpose. Here I'm just giving this a small number so that I can show you. In real world project, this number of requests can be vary based on your requirement. During DDoS attack, usually there is huge number of requests hitting the server, and rate limiting is one of the common ways that is used to prevent this attack. Surely, there are some other steps that needs to be taken to prevent the attack, but that's not our topic for today's video. We are only focusing on this rate limiting. Now, let's bring back the Spring Security dependency. Additionally, along with these dependencies, we also need to add another 2 dependencies. We'll use Bucket4j rate limiting library, so I also need to add this dependency in our project. Let's search for Maven Central. Here, this one. This is the site of Maven Central. This URL, central.sonatype.com. Get into this. Now click Browse. Here, first dependency I will search for is Bucket4j core. I'll use this one from com.bucket4j. Let's include this. Make sure this Apache Maven is selected. Copy this and paste it in our pom.xml file. Again, we need another dependency. Search for Bucket4j Redis. This one from com.bucket4j. Let's include this. Copy and paste to our pom.xml file. Now refresh the Maven project. Okay, now let's configure our Spring Boot application to connect with Redis. Open application.yml file. Here we'll provide a configuration of Redis, Spring, data, Redis, and host. I am running Redis on my local host, and then the port, it is 6379. This is the port that my Redis is using at this moment. Great. Now let's start coding our real Java code. Inside main package, create a new package, config. Inside the config, let's create a new Java class. I will name it ratelimitingconfig. In this class, we will define a couple of beans. Annotate this with configuration. Now, inside this class, we need to set up Redis connection details. First, let's create private field, type string, call it Redis host. We will get the value of this Redis host from application.yml. To fetch the value, annotate with value annotation. Make sure this value is imported from warg Spring Framework bean factory annotation. And here provide the property that we want to read from application.yml file. So quotation mark, then $, double bracket, inside, give the name of the property, spring.data.redis.host. And also provide a default value of localhost. So if we don't configure anything, the value of Redis host will be localhost. Next, let's create another field, private integer, call it Redis port. Annotate it with value. Here, the property will be spring.data.redis.port. Provide a default value 6379. Next, let's create our first bean. This will return Redis client and name the method Redis client. Here, this method will return Redis client dot create. Inside create method, we need a Redis URI because the client needs to know where this Redis is running. So let's start by building Redis URI, then dot builder. Now we need to configure it. First, let's set the host with host. This is Redis host. And next, set the port with port, Redis port. Now call build to finalize the URI. We have this bean Redis client ready to be injected anywhere. Now let's declare another bean. This one is the important one for Bucket4j. We want a ProxyManager and name it ProxyManager. This method takes Redis client as parameter. Inside this method, the first thing we need is a Redis connection. So call Redis client dot connect. Here, we need to define how keys and values are encoded because Bucket4j will store bucket state in Redis. Pass a codec Redis codec dot of string codec dot utf8 and byte array codec dot instance. Let's import this. Here, we are defining the keys as string in utf8 and the value are raw byte. Our bucket key is going to be something readable like an IP address or a user ID, but the bucket data itself is stored as binary. Now, store this connection to a variable named Redis connection. At this point, we have Redis connection that Bucket4j can actually use. Now, let's handle expiration. Without expiration, Redis will slowly fill up with bucket keys. For example, if we rate limit by IP, every new IP can create a new entry in Redis. If those IPs never come back, we don't want those keys living forever. So let's define a TTL strategy. Let's create expiration after write strategy based on time for refilling bucket up to max. Here, provide the duration dot of hours 1. With that, the unused buckets are removed after about an hour and assign it to the variable named expiration strategy. Next, we need to apply this strategy into Bucket4j client configuration. So let's create client config. This equals client side config dot get default, then call with expiration after write strategy and pass our expiration strategy. And now we are ready to build our ProxyManager. Return letUse based ProxyManager dot build for. Here, this will use Redis connection as storage backend. Then attach the client config with client side config, that is client config, and finally call build. Now the ProxyManager bean is ready. Now let's create a service whose job is ratelimiting. Create a new package, service. Inside service, create a new Java class. I will name this class ratelimiting service. This class is going to be a Spring managed service. So the first thing we do is annotate it with service. Now inside this class, we'll define our rate limit rule. So let's start with a constant. Private, make it static field. Final, type integer. Name this requests per minute. And this equals 10. This is the rule we want to enforce. A single client allowed to make 10 requests per minute. Next, we need something that actually store and manage the buckets. Since we are using Redis with Bucket4j, we'll use a ProxyManager.
We have created a proxy manager bin earlier. Let's inject it. So let's create a private field. Final proxy manager. This proxy manager is responsible for talking to Redis and keeping the bucket state there. Now we need to inject this dependency using constructor. Generate constructor, select the proxy manager field and click OK. Next, create a new method. This is our main method for this service. Public, return type bucket and name this resolve bucket. It accepts string key as a parameter. This method will be called for every incoming request. The key here represents whatever we are rate limiting by, like IP address or user ID or something else. Most of the time, it is usually the client's IP address. Inside this method, the first thing I will do is to create configuration supplier. Supplier parameterized by bucket configuration type, config supplier, and this equals, here we need to provide an atomic function, getConfig. Let's create this method. Let's replace this lambda expression with method reference. Here, this getConfig method will act as factory that produces configuration object for newly created bucket. This is where we define the actual rate limiting rule. This configuration will define two important aspects: how many tokens can a bucket hold and how quickly those tokens are refilled over time. We'll use bandwidth dot builder, provide capacity to request per minute. I want to refill at specific interval, so refill intervally. Here, as an argument, we need to provide the number of tokens, that is request per minute, and second argument is the period within the token will be fully regenerated, that is 1 minute. Call build to finalize the bandwidth rule and store it in a variable called limit. Now we need to attach this rule to a bucket configuration. Return bucket configuration dot builder, then add limit, provide a limit, and build. Now the configuration is complete. Back to the resolve bucket method. Here this returns proxy manager dot builder dot build, provide key and the config supplier. So this line simply asks Redis for a bucket for this key. If a bucket is already there, we just get it back. If it's not there yet, Bucket4j creates a new bucket using getConfig and save it in Redis. Next, we'll create our custom filter whose job is to intercept any incoming request, resolve the bucket using this rate limiter service, and decide whether the request is allowed to proceed or should be rejected. Okay, now let's create a new package, filter. Inside filter package, let's create a new class for our custom rate limiting filter. I'll name it rate limit filter. Now I want this filter to be discoverable by Spring automatically. So let's annotate the class with component. With that, Spring will create it as bean and we can plug it into the security filter chain later. Next, we need to extend once per request filter. There's a Spring filter base class that guarantees this filter runs only once per request. We don't want to accidentally check the same request multiple times. Now, inside the filter, we need to access our rate limiting logic. So let's create a private field, final, rate limiting service. Now let's inject it using constructor injection. Generate constructor, select the field and click OK. Next, I'll override a filter method. So let's generate, then override methods. Here, let's search for toFilter internal method. This one I'm going to override and click OK. Let's move this parameter to multiple lines. This method is basically the heart of the filter. Every request passes through here. We get the request, we get a response, And we also get the filter chain, which represents continue to next filter and eventually reach the controller. Now, the first thing we need is a key to rate limit by. In this project, we are using IP address. So let's extract the client IP address. String client IP equals. Here we can get client IP using request.getRemote_address. But it has some limitations. This returns the IP of the immediate sender. In production, you likely using Nginx, AWS load balancer, or Cloudflare, or something similar. The code will see the load balancer's IP for every request. As a result, we'll accidentally rate limit our own load balancer, blocking all traffic to our application. So instead of this, I would like to use better approach. Let's define a private method. This returns a string. Name it getClientIP. This method accepts HTTP servlet request. Inside this method, I will check the X forwarded for header to get the real user IP behind a proxy. This header is commonly added by proxies and load balancers. So, if your Spring Boot app is behind something like Nginx, an API gateway, or an cloud load balancer, in that case, request.getRemote_address might not be the real client IP. It might be the proxy IP. So, check this header first. Let's define a variable string. Name this xfHeader. This equals request.getHeader, and the name of the header that we have mentioned earlier, x-forwarded-for. Now, add if statement. If the header is missing or empty, we'll back to the request.getRemote_address. If the header exists, it can contain multiple IPs separated by commas because the request might pass through multiple proxies. The first IP is usually the original client. So let's split the header by comma and take the first item and trim, and finally return. Now back to the DoFilter internal method, and here replace this getRemote_address and call getClientIP method and pass the request. So now the filter has a reliable way to get the client IP. Next, we need to get the bucket for this specific IP. So bucket, name this token bucket, and this equals call our rate limiting service dot resolve bucket and provide our client IP. Now we'll try to consume one token from the bucket. Call token bucket dot try consume and return remaining, and provide 1 as the number of tokens. Store the result in a variable named probe. This call attempts to consume 1 token and also tells us how many tokens are left or how long the client needs to wait if the bucket is empty. Now let's check if the token was consumed. If probe.is consumed, if it's true, the request is allowed. So inside this block, add a response header, response.addHeader, name the header x-rate-limit-remaining, and its value is the remaining token count. So string.value of probe.getRemaining tokens. Now let the request continue. Call filterchain.doFilter and pass our request and response. So the request reaches the next filter in the filter chain. Now let's handle the failure case. This means the client has exhausted the request quota. Else, here, first calculate how long the client needs to wait before retrying. So call probe.getNanos to wait for refill and convert it to second. Store the value in a variable named wait to refill. Next, set the HTTP status response.setStatus
http status dot too many request dot value
and add a response header named x rate limit retry after seconds. Set its value to
string dot value of
wait for refill. Set the response content type to application JSON. Now prepare the JSON response body. String JSON response. I will use a text block to define JSON structure. This JSON response will have status. Add a placeholder for this. Then error. This is too many requests. Then message. This is you have exhausted your API request quota. Then retry after seconds. Provide placeholder. Then dot formatted. First value will be http status dot too many request dot value. And second one is wait for refill. And then write the response. Response dot get writer dot write and provide our JSON response. In this case, we don't need to call filter chain dot do filter. The request stops here and the client receives a 429 response. With this filter in place, every incoming request is checked against a Redis baked rate limit. If the client has token left, the request proceeds. If not, the request is rejected with a clean and meaningful 429 response. Next, we'll create a security configuration where we register this rate limit filter in the springsecurity filter chain. So it runs before our protected endpoints are reached. Inside the config package, let's create a new class for springsecurity configuration. I'll name it security config. Now, this class is responsible for defining the security rules for the application and also registering our custom rate limit filter in the security filter chain. First, annotate this class with configuration. Next, annotate with enable web security. This tells Spring that we want to enable Spring security support and use our own configuration. Now, inside this class, we need to access the rate limit filter. So let's create a private field, final rate limit filter. Next, let's inject it using constructor injection. Create a constructor that takes rate limit filter as parameter. Generate constructor, select rate limit filter and click OK. Next, let's create a bean for the security filter chain. Public method, this will return security filter chain, name filter chain. This accepts HTTP security and throws exception. Now, inside this method, start configuring Spring security using HTTP, then dot. First, let's disable CSRF. CSRF arrow CSRF.disable. In many stateless API scenarios, especially when we are not using browser sessions, CSRF protection is not needed. That's why I am disabling it here. Next, configure authorization rule. Authorize HTTP request. Then inside, provide lambda expression. Auth, arrow, auth. Here, actually I will define which endpoints are public and which one requires authentication. So, dot request matchers, provide the endpoint API, then /public /, and dot permit all. With that, any endpoint under this API public can be accessed without authentication. Next call any request dot authenticated. Now we need to register our custom rate limit filter. So dot add filter before. I want to run our rate limit filter before username password authentication filter. Finally, return http.build. Now our security configuration is complete. So these public endpoints are accessible without authentication and rate limiting is enforced early in the filter chain. Let's start the project and see it in action. Our project is started. Let's switch over to Postman to test it out. I'll send a request to this URL.
send. You can see we are getting a successful response. Let me show you the response header. See this X rate limit remaining header that we have added. Right now it's showing 9. This means we can send 9 more requests within 1 minute before the system blocks our request for the rest of that minute. Let's go ahead and send request 9 more times. That's 1. Still getting the same response. 2, 3, 4, 5, 6, 7, 8, and 9. Here in this header, it's now showing 0. If we try to send request now, look at that. The response status changed to 429, too many requests. Now let's check the response body. Here we have this response that we have defined. We have fields for the status, error, message, and retry after seconds. It currently says 8, meaning we can retry after 8 seconds. I think 8 seconds have passed already, so let's send the request again. Great, we're getting the response successfully. Let's try to exit the limit one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. As expected, we're getting the 429 response again, and this time it tells us we can retry after 52 seconds. That's how we can implement a rate limiting service in our Spring Boot application. By leveraging Redis, we made it distributed, making it suitable for use in a microservice architecture. Hope you have enjoyed this tutorial. Please let me know in the comments which topic I should cover next. See you next. Until then, bye bye.